In this section of 1-5 quadratic equations, we're going to be looking at the problems where you're asked to solve by completing the square. To solve a quadratic equation by completing the square, we have to make sure that two things happen. First, we have to make sure that the quadratic coefficient is 1. In other words, that the x squared only has a 1 as its coefficient. And in this case it does, so we don't have to do anything to adjust that. We also have to make sure that the constant term is moved over to the right side of the equation. And in order to accomplish that in this case, I will add that 1 to both sides of the equal sign. Doing that leaves me with x squared minus 4x on the left, and that equals 1 on the right. 0 plus 1 is 1. Now I have to decide what I have to add to this left side to make it a perfect squared trinomial, to make it something that I can rewrite as a quantity squared. And the pattern is always going to be the same. You look at the linear term, the term that just has the x, and specifically you look at the coefficient, which in this case is negative 4. I'll work off to the side here. I have negative 4. The first thing I want to do is take half of that. So whatever half of negative 4 is, in this case it's negative 2, I want to take that number then, that negative 2, and I want to square it, which gives me positive 4. So this number is the number that will be added to both sides of that equal sign. I still have the x squared minus 4x. Now I'm going to add 4, but in order to keep the equation balanced, I also have to add 4 to the right side. So this leaves me with x squared minus 4x plus 4 equals 5. What I've done now is I've created a situation where I definitely have a perfect square trinomial. I can always rewrite this left side as a quantity squared. And specifically, it's always going to be x, and then whatever half of that coefficient was, from way back when we looked at it and took half of that linear coefficient, whatever that number happened to be, that's what goes with my x. So in this case, that will be x minus 2, quantity squared, still equals the 5. I didn't change the value of anything, I just rewrote it. The reason for rewriting it is now it's in a form that's a little bit easier to solve. I have the entire left side as a quantity squared. I can solve that by taking the square root of both sides. So I'll take the square root of the left and plus or minus the square root of the right. The radical and the exponent cancel each other out, and I have x minus 2 equals plus or minus the square root of 5. To get the x entirely by itself then, I only need to add the 2 to both sides. My 2's cancel, and I'll write this over here. I'm left with x equals, it's customary to put that plus or minus in the middle of your answer. So my answer will be the 2, and then the plus or minus square roots of 5. For 35, again, we are responsible for making sure that the coefficient of the quadratic term is 1. In this case, we can't have that 2. To clear the 2, I will divide by 2. But whatever I do to one term, I have to make sure to do to all of the terms, including this 0, to make sure that everything stays equal. So I'm left with r squared plus 10r divided by 2 is 5r, plus, you are better off leaving fractions as improper fractions. In other words, writing 11 over 2 as opposed to 5.5 or 5.5. It's easier to work with these fractions when you have a single numerator and a single denominator. Equals 0 divided by 2 is just 0. I'm also, in addition to making sure that the r squared was by itself, I'm also responsible for moving this constant to the other side. So to make that happen, I can subtract 11 halves from both sides. My 11 halves cancel, and I'm left with r squared plus 5r equals negative 11 halves. Now to figure out what value I want to add to both sides, I look at my linear term, and the coefficient is a 5. So I will take that 5, and I will take half of it. In other words, I'll divide it by 2. and 5 over 2 I'm just going to leave as 5 over 2. What I want to do then is I want to take that 5 over 2 and I want to square it. To square a fraction, you can square the numerator and square the denominator. So 5 squared is 25 and 2 squared is 4. This is the value that I will add to both sides. So that leaves me with r squared plus 5r plus 25 fourths equals negative 11 halves plus 25 fourths. The left side is now definitely a quantity squared. Specifically, it is r, and then whatever half of that coefficient was, whatever half of the 5 was, which we said was 5 over 2. So this factors into r plus 5 over 2 quantity squared equals, don't get lost with the fractions, negative 11 halves, I'll write this up here, negative 11 halves, if I want to rewrite that to have a denominator of 4, well, it was 2 times 2, which gave me 4, so whatever I do to the denominator, I have to do to the numerator. So negative 11 halves is the same as negative 22 fourths. So negative 22 fourths plus that 25 fourths just gives me 3 fourths. So when I take the negative 11 halves plus 25 fourths, I'm left with 3 fourths. So this is the equation that I'm at right now. The quantity r plus 5 halves squared equals 3 fourths. I want to now take the square root of both sides. I have the entire side being squared. Equals plus or minus, the square root of a fraction is just the square root of the numerator over the square root of the denominator. If I simplify this then, the radical and the exponent cancel each other out, and I have r plus 5 halves equals, the square root of 3 is just the square root of 3, so I will say plus or minus the square root of 3, over the square root of 4 is just 2. To get the r by itself then, I'll subtract the 5 halves from both sides. My 5 halves cancel, and I have r equals. Both fractions have a denominator of 2, so I can write my fraction as a single fraction with that common denominator of 2. We want to keep the plus or minus in the middle, so I'll start with the negative 5 in the numerator. And I will say negative 5 plus or minus that square root of 3. So my answer is r equals negative 5 plus or minus square roots of 3 over 2. For this one, I have to notice that the u squared has to be by itself, so I have to divide everything by 4. Dividing everything by 4, including the constant and including this 0, leaves me with u squared plus 2u plus 15 fourths equals 0. I want to keep the 15 fourths as 15 fourths. I don't want to rewrite it as a mixed number or as a decimal. I'll subtract the 15 fourths now because I have to move the constant over, which leaves me with u squared plus 2u equals negative 15 over 4. To decide what number to add to both sides, I will look at my linear coefficient, which is 2. So I'll start with that 2, and I will take half of it, which gives me 1. Then I have to square that 1, which still gives me 1. So I'm going to add 1 to both sides, which gives me u squared plus 2u plus 1 equals negative 15 fourths plus 1. To simplify the left, it's always going to be u, and then whatever half of the linear coefficient was, so half of 2 is 1, so I get u plus 1 quantity squared equals, please don't get lost with the fractions, I have negative 15 fourths, plus 1 I can just rewrite as 4 fourths. Adding my numerators gives me negative 11 fourths. So I have u plus 1 quantity squared equals negative 11 fourths. Since the entire left side is being squared, I can take the square root of both sides. To take the square root of a fraction, I'll take plus or minus the square root of the numerator over the square root of the denominator. The radical and the exponent cancel each other out on the left, so I have u plus 1 equals plus or minus the square root of negative 11 is just I square roots of 11 over the square root of 4 is 2. I can subtract the 1 from both sides to get the u by itself, so I'm left with u equals. The negative 1 is the same as negative 2 over 2. So I can still rewrite my answer with a common denominator of 2. The plus or minus will go in the middle, so I'll start with that negative 2 in the numerator. I will have negative 2 plus or minus I square roots of 11. Finally, for number 39, again, I want to start by making sure that the quadratic coefficient is a 1, so that means I have to divide everything by 3. Doing so gives me w squared plus 4/3 w plus 3 divided by 3 is 1 equals 0. Now I have to move the constant to the left, so I'll subtract that 1 from both sides, which gives me w squared plus 4/3 w equals negative 1. The process is still the same. The fact that the linear coefficient is a fraction does not change the process. If I start off with 4/3, dividing something by 2 is the same as multiplying by 1/2. So taking half of 4/3 just means taking 4/3 times 1/2. To multiply fractions, we multiply straight across. So I have 4/6, which simplifies to 2/3. So half of 4/3 was just 2/3. I have to take that number then, the 2/3, and square it. To square a fraction, I square the numerator and square the denominator. So the number that I want to add to both sides is 4/9. So this leaves me with w squared plus 4/3 w plus 4/9 equals. At this time, I'm going to take the negative 1. Negative 1 is just negative 9/9. I'm writing it that way because I need a common denominator. So let's kind of say where we were again here. I had the w squared plus 4/3 w, and then I added 4/9, but whatever I add to one side, I have to add to the other side. So that equals, the negative 1 is just negative 9/9 plus 4/9. Again, please don't get lost with the fractions. All I did there was rewrite negative 1 as negative 9/9 so that I had a common denominator. The pattern is still the same for what I'm doing. To factor w squared plus 4/3 w plus 4/9, I have w and then plus whatever half of that linear term was. Since my linear term was 4/3, up here we established that half of 4/3 is 2/3. So this factors into w plus 2/3 quantity squared equals negative 9/9 plus 4/9 is negative 5/9. Since the entire left side is being squared, I can take the square root of both sides. The square root of a fraction is just plus or minus the square root of the numerator over the square root of the denominator. So I am left with w plus 2/3 equals plus or minus the square root of negative 5 is just I square roots of 5 over the square root of 9 is just 3. And then finally, I want to subtract 2/3 from both sides, which leaves me with w equals. My fractions both have a denominator of 3. I'll start with the negative 2 so that the plus or minus stays in the middle. I square roots of 5. So my answer is w equals -2 plus or minus I square roots of 5 over 3.